we would imagine that AR and VR is going to be very central. Um, and the challenges you need to solve, particularly for AR in relation to the real world. Uh, the kinds of technologies you need to develop and the data you handle um, are in ways applicable across all of these industries and can be help us to interface with all these. So our natural human interactions mediated by AR will allow us to interact with a digitally upgraded smart world. Everything within it, the smart robots and vehicles, the IoT devices, the whole smart city, the digital twins. So how are things going today? This this picture here is indicating how important many of the big players think this is. They are investing in aggregates tens of billions of euros every year towards real-world spatial computing and AR, VR. However, um, even though that is bringing massive technological improvements, we see devices improving every year. We see algorithms, positioning, reality capture technologies are advancing in a very encouraging pace. There are some big issues. One of them is obviously that um, some of these platforms that are being developed are proprietary walled gardens that do not work well together. So within those walled gardens, the big companies, based on maybe their current business model, they set the terms, they decide how things should work, and they might not be all that interested in having the experiences that are developed for their platform work on somebody else's platform. That might be a good thing for one of these companies, but it's devastating for the whole industry and for the users and for the businesses that don't want to be tied in, to be locked down with one of the providers, or to have family members using a different device not being able to take part in the same experience. That's a really bad pattern. And there's another even more, uh, what should we say, is a bigger concern, and that is related to how data is managed, particularly with regards to topics such as privacy, safety, security, accessibility. So there's a range of ethical concerns that uh, we might not see addressed in the proper way when the whole industry is configured in this way. So um, starting with the interoperability part, we already know from experience that there is sort of a solution that has proven to work. So uh, all of the industries on that previous side, they have some sort of interoperability through the open web platform. They are connected, but they are not connected in the spatial context. The web really proved to be massive success when it comes to scalability and interoperability across industries. But now we see that there's a need for some new improvements that we hope can be added to the ecosystem of interoperability, something that could bind together all these things. So that is where our ideas for the open spatial computing platform fits in. So we hope to push the world in this direction. So with that, I want to hand it over to James Jackson, who can take us through the architecture, the principle of the architecture for the open spatial computing platform. Let me see if we have him now.
Hi, James Jackson here. I serve as the Volunteer Director of Technology at OpenAR Cloud, and I'm going to drill into some of the details behind our open spatial compute platform. So one of the core philosophies of OpenAR Cloud is to build open source reference implementations that help move the industry ahead. What I'm showing here is the high-level architecture of OSCP. Starting off at the top, you see that we have services that are home to the country level, such as spatial service discovery. And then lower down, we have services that exist in what we call a geozone. A geozone could be a town or a city, and most likely these services would live very close to the users, so in some sort of an edge cloud as an example. Now, touching on the color scheme here, you'll notice we have some services shown in yellow, which are fully specified by OSCP. And what this means is that we define not only the APIs and the data models, but also the internal design and implementation details. That's the case for services such as spatial discovery. We have others that are shown in gray, where these are partially specified. For these, our focus is more around the interoperability rather than the actual internal implementations. So we focus on the data model, the APIs, the data exchange, but there may be a whole range of different implementations from proprietary implementations to open implementations. And this is the case for services such as GeoPose and reality modeling. So let's step through the typical flow of a client interacting with these services, right? So imagine that we've got a user wearing smart glasses. Most likely this is 5G connected. So we need the characteristics of a 5G environment, high bandwidth, low latency. And as I mentioned, these services most likely reside in some form of an edge cloud. So we've got OSCP client libraries that are interacting with the services. Our very first step is to query spatial service discovery. And spatial service discovery is essentially going to help us discover these lower level services that are available in the geozone. You could think of spatial service discovery as being similar to a DNS hierarchy. So it may be homed to a particular country and operated by some sort of foundation. But essentially, it's a mapping of coverage polygons and their associated services. So the characteristics for those services, the URLs to contact those services, etc. Once we've discovered which services are available, we move on to the next step, which is finding our geopose. Geopose is really an accurate representation of our position and orientation in a common real-world coordinate system. Now, we've been working with the Open Geospatial Consortium, the OGC, on specifying a standard representation for geopose. We've also defined a geopose positioning protocol. This is essentially a localization protocol that allows clients to stream sensor data into a positioning service. This could be information such as camera images, IMU data, GPS information, essentially any sensor data that helps with the positioning task. The positioning service then in turn provides the geopose associated with the client. And again, that's the accurate position, ideally down to centimeters, and accurate orientation of where you're facing to within a few degrees. Now, geopose services today are largely based on vision or computer vision approaches. You'll often hear these referred to as visual positioning services. And we have several partners, including Augmented City and Immersal, that have implemented support for the geopose representation, as well as this geopose localization protocol. And they've also implemented support for interacting with our spatial discovery services. So now that we have our geopose, we know precisely where we are in the real world. The next step is to discover spatial content. And spatial content discovery allows us to do this. Spatial content discovery helps us find virtual content like 2D or 3D assets that are anchored in the real world, or even richer immersive spatial experiences that have some jumping off point in the real world. Spatial content discovery and also spatial service discovery are really using lightweight JSON records. And spatial content discovery has pointers to external content, so the content itself doesn't live in the service. And then there is a geopose associated with that content, so we can accurately anchor the content in the real world. Both service discovery and content discovery are designed on a decentralized web fabric. The idea here is that we want to allow multiple providers to contribute to a shared spatial index. You could think about this as being sort of like web search for the spatial web, where we're trying to democratize this idea of search. We want to ensure that anything that is indexed is available to all users who have permissions to see it. So we avoid this idea of silos where you only see content depending on which particular ecosystem you're connected to. So now that you've discovered the spatial content, we move on to the very last step here, which is reality modeling. Reality modeling is still very much so an emerging concept. There's a lot of work here to do, and it's in the early stages. But reality modeling is where this digital twin of the real world ultimately lives. The digital twin includes static layers such as your roads and your buildings, but it also includes dynamic layers such as people and cars, and a real-time representation of, you know, where they are and how they're moving and interacting at any given moment. You can imagine that there's a tremendous possibility for future research in this field and new services that will evolve as a result of this. We envision that we get to a mode where, you know, you've got this rich semantic understanding of the real world and even how objects relate to each other through dynamic scene graphs and things like that. But you know, in its simple form, you can imagine a structured model of the real world where you've got publishers and subscribers for that data, right? So you've got people that are contributing to building the model, and then you've got clients that are subscribing to a feed of that model. If you take one of the simplest use cases today, that might be occlusion. So if I've discovered all this content through spatial content discovery, but perhaps there's a tree or a building between me and the content, then I ideally shouldn't be showing that to the user, right? The richer these spatial experiences become, the more important it is for them to interact seamlessly with the real world around them. Now, some of these other services that I'm showing here in orange, like the actual content hosting or some of the higher level intelligence around the specific experiences, as well as cloud rendering, are not specified by OSCP, but they're certainly important pieces of the overall pipeline. So moving on to some of the specific details, we'll start with spatial services discovery. As I mentioned, you can imagine this as 2D coverage polygons and their associated services. Here you see a sample map showing some of those coverage polygons. You can see that there is a REST API that provides access to this data. And over here, we have actually a sample spatial services record. And you'll notice that it's using standard GeoJSON to define the polygon. The actual coordinates aren't shown here to save space. And then we've got some characteristics for the services. In this case, it's a GeoPost service, and this is how we contact it. I've listed here the GitHub repos for the services, so the core service itself. which, as I mentioned, is built on this decentralized web infrastructure. There's a running prototype of it hosted in AWS where you can experiment. Anyone has read access to this, so you can try some of these values. You would need an account to be able to create records. And then there's a client library that facilitates efficient interaction with the service. Similarly, for spatial content discovery, in this case, we're discovering the actual virtual content in the real world. You see here in this example that we've pulled in a 3D model of Bender. This is a GLB of Bender and the associated geopose for him. So we can now place him accurately in the real world. Again, you'll see that it's standard REST API, and we have an example of the spatial content record here. So you see the reference to the GLB that was pulled in and the associated geopose. Once again, we've got the GitHub repo for the core service, running prototypes hosted in AWS, and client libraries for simple interaction. This shows sort of the high-level topology around spatial discovery. So as I mentioned, you've got spatial service discovery, which is homed to a given country. So, first we have to determine which country's spatial service discovery service we're connecting to, right? That top level may be operated by some form of foundation. And then we've got multiple providers in a given country contributing to this common index. And again, this is service discovery, right? Now we use service discovery to discover the other services that exist in the geozone. So then we drill down to a particular geozone or city. I'm showing some examples here, Helsinki, Finland, and Bari, Italy, because this is where some of our partners are running real test beds today. So we've got Immersal running a live test bed in Helsinki, Finland, and Augmented City running a test bed in Bari, Italy. What you'll see here is that we've got geozone-specific services, such as spatial content discovery. Again, you can have multiple providers in that geozone contributing to a common index for the content. And you can have multiple geopose providers and communicate with them via that standard geopose protocol. I mentioned a decentralized web technology, and today that is based on the Hypercore protocol. You could think of this as being in ways similar to Git, but you're synchronizing all changes in real time, and it's designed to deal with very large amounts of data. We also use certain implementations of a decentralized OpenStreetMap architecture for the core today. And this last one is geopose. So I mentioned that it's the representation as well as the localization protocol. If you look at the GitHub repo for geopose, you will essentially see a specification for the protocol itself. So that essentially defines how you provide and structure all your sensor data that is provided to the geopose service, and then the geopose structured response that comes back. This is implemented today by several of our partners. In addition to the core repo, you will find client libraries, again, specific to geopose. And there's an excellent demo that you can look at here, which essentially walks you through the stages of discovering a geopose service through spatial services discovery, connecting to that geopose service and providing image data, getting your geopose back in response, and then placing that particular image in the real world based on the geopose in a 3D tiles model. Let me touch a bit on the future. These are very early days for us uh, in OSCP, and there's a tremendous amount of work to be done. So we encourage anyone that's interested to come and join us and help contribute to this vision. Some of these items are maybe smaller efforts, and some of them, as you'll notice, are much larger, right? So this first one is around an idea of having restrictions on spatial mapping and augmentation. So we think it's really important that we be able to control a particular setting, such as your home or your business, and that you have policies that dictate who's allowed to map in those areas, who's allowed to access maps, who's allowed to create augmented content, to view augmented content, right? And a lot of that can be at the highest level control through a special set of service records. Along similar lines, we start off thinking of the public first scenarios when we follow the web model, but of course, private and hybrid scenarios are also very important. So again, going back to the example of your home or your business, you most likely don't want this data to be public, right? So there's this aspect of a decentralized identity scheme and being able to control precisely who has access to which pieces. So that's going to be a very important piece of integration or architecture to evolve going forward. We'd like to look at creating an open source reference geopose localization service. So we're working with some of our university partners and other OR partners on this effort. As I mentioned, geopose services may be proprietary, they may be open, there is no set standard around this, and the idea behind the reference service is that it helps foster some R&D and innovation in this particular space. Very important aspect is the deployment topologies of these various components, how they fit into a 5G world, an edge cloud world, how distributed that particular edge cloud is, how close it is to the end devices, as well as moving functions between end device and between edge cloud. So there's some intelligent split that can occur here for different services. So there's a lot of work to do around prototyping these deployment architectures, ideally in real world test beds with 5G and edge cloud available. I mentioned visual positioning services, but visual positioning is only one particular modality. There are many different ways of doing positioning. As an example, in autonomous driving, you often use LiDAR sensors, right? It turns out that with 5G millimeter wave, it's theoretically possible to get very precise position and orientation information through trilateration type schemes. The standards around this are still evolving and not quite available in the real world yet, but we expect to be seeing them over the next few years. So it's interesting to think about some of these other positioning technologies, and it's not as if one is better than the other. They really complement each other in different scenarios. So you can imagine sort of hybrid architectures. Some technologies work better in rain, some better in indoors versus outdoors, or at night versus during the day, right? So it's very interesting to look at this mix as we move forward. I mentioned that reality modeling is really in the early stages. So at this point, there is no standard modeling language and no standard protocol to specify the communication associated with that language, and how we move towards this idea of a shared model of reality. So that there's a tremendous amount of work that has to be done in this space. And that includes not only the data model and how we interact with it, but this whole aspect of spatial data exchange, right? The same may apply to positioning services. Ultimately, you can imagine that that spatial data on the back end sort of converges the data that's used for localization, which today is more so sparse point clouds, versus the data that's used in your reality model, which might be more of a structured representation of the real world, right? But we see that sort of coming together. And then the important aspect being the creation of a spatial data exchange around all of this information, and doing it in such a way that, of course, we honor the privacy of the end users and make sure that it's an incredibly secure environment. So thank you again for your time, and we encourage you to join us on this journey. Thanks.
Thank you very much, James. That was a very good overview of the architecture and the reasoning behind. Now it's time for Susan to walk us through the schedule of this tutorial. Are you there? You are muted.
Okay. So I am just going to briefly go over the week so that you guys know what to expect. Can you see my screen okay?
Yes.
Okay, thank you. So as you probably already know, you're sitting in session 1 right now, getting the overview. Session 2 is where we're going to actually teach people how to build their own point cloud and assign and upload objects in it, and also do some rich interactions, which are very much in the experimental stage, but definitely a lot of things for you all to play with. And there'll be several different tracks that we'll talk about in just a minute. And then, as most of you probably know, we're going to end next week on Friday with an opportunity for people to present what they've worked on. And so this is the week overview, and this is the Zoom link. All of our sessions will be using the same Zoom link that you used today. And there we go. Whoops. In order to participate in our coding sessions, we're asking everyone to please register with us. We have a lot of information to get out to you. There's some things that you have to do in regards to providing information about your location, and we need to be able to send you test packages on test flight for applications that you're going to be using. So it's very important that everyone please register if you're planning to go along with us and code something over the next week. You can get the information. The link to the sign up form is on our website, openarcloud.org, IEEE VR 2021. And the partners who are going to be presenting their technology in session 2 are Augmented City and Immersal, as we've already spoken about. Our web client that's been programmed from Michael Vogt here internally at AR Cloud. We've named it Sparkle. We won't be actually doing an official public announcement about that until next week when our branding is complete, but we are giving you all a sneak peek this week at it. And then as John Eric already explained, we're happy to announce Zappar, a new partnership, and they will be presenting their technology, an overview of their technology and where we hope to go with it in terms of our partnership. But that technology has not been integrated yet, so we won't actually be using it in the workshop, but definitely a goodie to come. We're very excited about it. And so I'm going to give the people who are presenting tracks during session 2 an opportunity to give a high-level overview of their product, so you can start to think about what track you might want to participate in. So Miko, would you like to talk? Do you want the screen, or is this slide okay?
Slide is okay.
Okay.
So hi everyone, my name is Mikko Karvonen. I'm Chief Product Officer and co-founder at Immersal. I'm also, should I start my video? Yeah, sorry.
Yeah.
For that. So I'm also a founding member of the OpenAR Cloud Initiative, as well as coordinator of the Helsinki testbed. So Immersal is an augmented reality startup based in Helsinki, Finland. And we specialize in mapping and localization. Our product, the Immersal SDK and cloud service, can be used to map or scan any real-world environment, which allows for any device with a camera, like a smartphone or an AR headset, but also a robot or a self-driving car, to localize itself to that map. In an AR application, this allows for persistent multi-user AR experience where people can see the same content at the same location and can also interact with it together. My tutorial today will be our city scale demo app, which can be used to quickly scan a space, which will then become AR enabled, and you can add virtual content to that space. It has some basic multi-user functionality as well, so all devices can see the content at the same place and users are able to move the content around. I will show how to set up the project in Unity, how to build it, and how to start customizing it with your own content. It's a simple yet quite powerful demo, which can be used as a basis for a more complicated AR experience. The source code for the demo is available on our public GitHub repository, and you only need to register a free Immersal account on our developer portal to build the demo and start building AR experiences of the future. In this demo, all AR content is actually positioned in global coordinates, namely latitude and longitude. This and the geopose localizer in the demo makes it possible to, for example, view a location in Google Maps, get those coordinates, and position AR content to that location. For example, I'm here in Helsinki, but I can add content to, say, Central Park in New York, and then people with the app could go see it there immediately. What makes Immersal's offering special when compared to, for example, Google Cloud Anchors or Microsoft Azure Spatial Anchors is that the user can actually download and own the map data himself, so it's not inaccessible in some walled garden. We also offer a standalone server solution for enterprises, which can be installed, for example, on a 5G MEC container, which doesn't even have to be connected to the internet. So in locations where privacy is the key, our solution is the best option. We also offer both on-server and on-device localization depending on the application. Either one can be used, as well as a hybrid solution where the initial geopose localization happens on the server, after which the map data can be downloaded onto the device, and subsequent localizations can be done on device, even without internet connection. Immersal is a founding partner of the OpenAR Cloud, and we're committed to adding support for the open spatial computing platform in the coming weeks. Thank you. Okay,
Miko, thank you so much. And I'd like to now introduce Vladimir Ufnoroski of Augmented City, and he's going to share. Vladimir, are you here?
Yeah, hello.
Okay, there you are. Hi.
Hi, my name is Vladimir, and I am a co-founder of Augmented City. We are Italian company, Italian startup, and we are running the biggest test bed for open air cloud. So probably the biggest test bed in the world. So right now, the coverage of our AR cloud spans for more than 200 square kilometers and covers more than 100 cities worldwide. So we have locations, biggest one here in Bari, but we also have locations in a lot of cities in Europe, in the United States, Asia, well, everywhere. And we are growing quite quickly, adding more and more spaces to our AR cloud. And during these tutorial sessions, our friends and partners from uh, different companies will show how they use our technologies, how they can easily map uh, the big locations. So we are initially rented for city scale and bigger locations, and then how to add persistent 3D objects there, how to deal with them, how to work with them remotely, and lately where to take the open source Unity-based application that allows to view and operate those objects. So based on this technology, we have a number of very nice virtual demos on the big areas, like more than 1 square kilometer demos, and we welcome everybody to share uh, their thoughts with us, to work with us. So for those who does everything, who does the mapping by themselves, our technology is completely free. Uh, and definitely we support Air Cloud initiative, uh, and working together to make the future happen, to make the air cloud technology to help in everyday's life. So hope to see you on our track. Thanks.
Okay, thank you so much, Vladimir. And on behalf of Michael, myself, and Gabor Soros will be presenting on his behalf. He is not available for these sessions today live, but he's going to very much be available asynchronously during the week. He is the author behind all of our web-based applications, and he's worked really hard to provide tools that will allow participants today to build great experiences using the everything we've put together, the client implementing what James was talking about. So these are the 3 tracks that will be available in session 3. Each technology will give you a little bit deeper dive, but still an overview. And then you'll have an opportunity to decide which one is most interesting to you. The 2, Immersal and Augmented City, are based in Unity. The browser-based Sparkle is going to be based in, obviously it's web-based. So depending on what you're comfortable with will also obviously impact your decision. We ask that everyone bring an open mind and an attitude of experimentation. Most of what Michael has, he calls every single one of what he's done an experiment, even if it's working great. We're all in this together, exploring, and we hope that you enjoy the sessions and what we put together, and continue to participate and continue to build along with us even after next Friday. And then our closing session, when we do the presentations, we have a stellar lineup of review panelists: Ori Inbar, Kathy Hackle, Jimmy. Do you want to take that one? Jan Erik, last name?
Jimmy Alam Parambil. I would
Okay.
hope that was correct.
And he's from, I'm sorry, Ori Imbar is from AWE, Augmented World Expo, and Super Ventures. Kathy Hackle is from Immersive Futures. Sorry, Kathy. And Jimmy's from Adobe Aero, and April Spate is from Microsoft. So they're going to be looking at everyone's submissions prior to Friday to get a feel really for who's been able to accomplish what. And then Ori's going to select, the panel is going to select a few winning options, and Ori will be providing free passes to the upcoming live and in-person AWE scheduled in Santa Clara for this fall. With that, I am complete, and we can go to questions and answers.
Yeah, I already saw that there was two questions. So one is very practical about the slides. People want to be able to download slides that had links in them. So where should we publish them, Susan?
I'm sorry, publish what?
The slides that were presented here today.
Oh, so I can link to them in there's a document called Getting Started, and we can provide the links in that document.
Yeah, we might also put some links in the GitHub repo. We'll look into that. Then there was a question about, hi, thank you for the interesting talks. The open air cloud vision seems to be very related to outdoor urban scenarios. Could you explain whether public indoor scenarios, such as museums, libraries, if they were considered or if they were left out? They are absolutely considered. We are thinking of this platform both for the indoors and outdoor scenarios. It's intended as a universal real-world spatial computing platform. And also our partners who are doing visual positioning can support both indoor and outdoor scenarios as out of the box. Some might work better in some conditions than others. But we're early in this phase, but we want to work everywhere. Right, so let me see, there are, you can also raise your hand or maybe unmute yourself if you have a question.
And Jan Erik, just to piggyback on what you just said, one of the things that we will be talking about in session 2 is how to create a quality point cloud and what's easy to scan and what doesn't work so well. So those are some of the parameters we'll be discussing.
Good point. There's another practical question. Will session 2 be streamed like this one? This is one for you, Susan.
The first part will, but the breakout sessions will not be streamed because we're going to have 3 parallel tracks. But all of the documentation for all of the tracks will be available to everyone. Just because you pick a particular track today doesn't mean like you're stuck. You're welcome, and we invite you to play around with and try all of the different technologies.
Then I actually have a question for those who intend to participate in trying out the platform. If you are on Discord, if you have been given the proper access to the channels where you can ask technical questions and interact with the team from OpenAI Cloud. If you have not gotten the access, you can reach out to me or Colin, and we will give you the permissions that are needed.
Yes, I'll be watching and can give people access. You can message me through Discord, either on our Discord or on the IEEE VR Discord, and I'll make sure that you have access for our tech support channels.
I see a few people have made it. So there
Yeah.
is a welcome email. As soon as when you register, I'll be able to send that out to you with all the information about where the getting started is, the Discord, how to get access to the apps. All of that will be provided.
Yeah, that's a very good point. That link, like Susan mentioned earlier, is on our website. The link Rolf just shared in chat, openarcloud.org/IEEE 2021. If you fill out the registration survey, we'll see it and send you early access links and everything else.
So if everyone is shy, you can write in the chat. So now, okay. Saeed asked, in terms of ownership, who control what people can post around the city? For example, if AR content is placed on a government building, would there be any way to control it by local councils? That's an excellent question. And the position of OpenAI Clouds with regards to this is that we want sort of we the people, any local government is the right authority to make those decisions. It is not the place of OpenAI Cloud to decide, and it is definitely not the place of a private corporation to make those decisions. It is much better, like we have been working with democratic societies for let's not throw all of that away. Let's have the authority where it belongs. The people should decide, and by that it's the governments that are elected by the people. So at least for the democratic parts of the world, which is most of the world by now. So what we want to do, Colin could probably speak to this.
Sure.
Yeah, you want to have a go right now?
Yeah, so this is one of the things that we're exploring really through our testbed program. This issue sometimes I refer to as provenance. You might have seen that the Spatial Discovery Service, one of the features we're working on is adding early compliance records, specifically a do not map record and a do not augment record. So that someone, for instance, a city council could draw a geofence around a government building and say, please do not capture this data and contribute it to public point clouds. And once that record exists in the Spatial Discovery Service, we have to look at who posted that record and determine if they have authority over this domain. And the reality of this is that has to be different for different places across the world. In order for this platform to be ubiquitous and global, it is going to have different policies for different regions. And so through our testbed program, we're working with early partners to develop some practical methodologies for making this decentralized and something where different spatial service discovery operators in different regions will be able to implement a compliance model that is going to work with their region. So we have some early harnesses, I guess I would say, interfaces intended to enable some of these privacy, security, compliance issues, but there isn't going to be one size fits all solution for this. And so we this is one of the reasons to come and collaborate with us and contribute to this effort, is so that we can develop a model of provenance and authority that is going to be decentralized enough to be truly global.
Yeah, it's a good point. Another aspect maybe to consider, there's a distinction between sort of the public part of the future spatial web, places where everyone can go around, like the streets and inside of museums or train stations. Those are like our public arenas. And that is sort of like the open web, but from web technology, we also know about how companies have had their own sort of internal versions of the web intranets, and that could definitely be a possibility for an industrial facility or a military facility or a health care facility, that there are sort of instantiations of the same platform. So it just continues to work with all your devices and all your data sets. But these local versions of the open spatial computing platform are not part of the public. They are managed by those who control it. It could actually be inside of your own home. You could have your own little open spatial computing platform that works for your friends and family and nobody else. That is part of the thinking.
Well, it's 9 minutes to the end of the session. Is there anything else we should cover before wrapping?
If nobody has questions.
Oh, there's a question. What is the current level of accuracy of anchoring within a space? That could be a question for both Mikko and Vladimir. You want to go first, Mikko?
Okay. So it actually depends a lot on the quality of the map. If the map is of very high precision, then the accuracy in our solution can be centimeters or even 1 centimeter. But then in larger spaces like outdoor spaces, the accuracy gets worse the farther the location is. But then it doesn't really matter, because on your small display you cannot really see the errors that much. And then when you get closer to a location, also the localization results get more accurate, and then that kind of fixes itself when you get closer. But basically it works pretty well in a room scale setting. Everything can be positioned very accurately, and they only drift maybe a few centimeters. But it's a matter of many things, because we are also using the device tracker ARKit or ARCore, and that can also mess up with the tracking. But
how about you, Vladimir? Do you have an estimate of accuracy?
Yeah, so as Miko said, it definitely depends on the scene, but I'd say for us the typical precision for outdoors, big outdoor scene is like 10 centimeters, so sounds like this. And as Miko said, it can, there are two kinds of precision. So first is the localization precision itself. So how precise your camera, the coordinates of your camera is located. And the second is the tracking precision that highly relies on our core kit algorithms and the environment. So this may differ. But typically, yes, the typical localization precision is much better than what we can see from GPS or similar techniques that can be tens or even hundreds of meters.
yes, definitely.
There's
cheating
another
would be
question maybe you can answer regarding possibility to use HoloLens or such AR devices.
Yep.
Does any of your solutions
Yes,
provide support for that?
Yeah, that's possible. So as we use Unity as a rendering engine and tracking engine, Unity is supported by HoloLens too as well.
Miko, is that you also can confirm?
Well, we haven't added HoloLens support yet. It's on the roadmap, but basically it's just a matter of doing a new localizer class for that. But basically, you need to have camera capture from the HoloLens device and then use the image data from that device. So it can be done, but we don't officially support it yet. We have support for Magic Leap and Nreal headsets, and HoloLens is coming.
Great, thank you.
But if somebody manages to add HoloLens support during this session, I wouldn't mind.
Is there a prize if they do? Well,
we will send something, yeah, for real.
that's wonderful. Yeah, now we have a challenge here for the really ambitious developers.
Yeah. But you can
honor and glory
look
prizes from Immersive.
Yeah, you can take a look at the Magic Leap or Nreal examples on our GitHub, and it's just like one class that you have to implement. So.
Great. I think we have 3 minutes left. We can take one last quick questions probably if there are any. Are there any laggards who has been keeping the questions inside of them? Now is your chance. Regardless, if you don't have the question right now, we are on Discord, so we'll try to be responsive during the week. We have a whole team of volunteers who have worked very hard for a long time towards this moment and are eager to help.
The code that you will be exploring this week is freely available moving forward, but you should all feel honored because this is really the first release of a lot of these early implementations to the public. So we're very grateful to have you be our first wine tasters testing out this technology. And we couldn't ask for a better platform than IEEE to have this showcase.
Yeah. I put the link again for signing up for session 2 for those of you that are not signed up. Again, in order to get access to all of the information, you'll want to sign up so that we can make sure you're on target and have everything that you need. Okay.
Yeah, so with that, I want to thank all of you who showed up for this event, and a big thank to all our volunteers who have worked for this, and especially a big thank to Susan for being the main organizer. So bye bye everyone.
Pleasure.
Bye bye.
Bye bye.
Thank you, guys.
Thank you. Bye bye. Take care.
Thanks, everybody.
Long and prosper.
I'm sorry, what is that option?
The options are automatic assignment, manual assignment, or letting the participants of the call be choose which way they want to go, which room they want to choose.
I think we should let them choose, but again, let's give it a few minutes. Maybe 5 minutes into the session, we can see how many attendees there are.
Yes.
Can you guys see my screen?
Yes.
Yeah, it looks
Great.
good.
Hoping my dog will be quiet during my presentation.
Yeah, I've got a puppy here and she's downstairs, hopefully being quiet as well.
Is this a new puppy?
15 weeks.
Oh boy, what kind?
Yeah, Labradoodle.
Oh, those are good dogs.
But she's just discovered how to bark.
Oh
and
no.
is testing her limits. So it's a. Oh, I can hear her, but she's
and
far away.
yours, I would imagine. Stretching her limits and yours.
Yeah, yeah, but also good time to get a new pet during the pandemic.
Right.
Excuse me, Colin. Do we have to sing in any other application to receive feedback from the attendees?
I'm sorry, can you say that again?
Yeah. Do we have to sing into any other application to receive feedback from the attendees? Like I have way too many windows open over here, so I don't want to open more.
I think for now it'll
like
just be
Discord.
Yeah, I mean,
Okay.
I think people will more be using the Discord in between sessions for support as they work with the code. So I think just focusing on the chat built into Zoom for the next few hours is fine.
Okay, thank you. In any case, I am a little bit scared of my own presentation using the same technology to showcase the concept. So let's see how it goes. Good luck, everyone.
You too.
Colin, do you have a list of registered participants registered on our side?
Yeah, let me look at that. I also have a lot of windows open, right?
Yeah. It's crazy.
I have 3 screens and it's still not enough.
See, it's 11 o'clock, but we've got one person trying to connect here. So why don't we give them another minute here to see if they can get through before we start. And Colin or Susan, did you guys want to say a few words to get started, or should I jump in?
Why don't we start 3 minutes after the hour just to give
Sounds
stragglers
good.
a little bit. So
Sure.
for those on the call already, thanks for attending. Like I mentioned in the last session, this is really the first time that members of the public have gotten to try out any of the components of the open spatial computing platform. So it's very exciting now that we have GeoPose and Spatial Discovery Service far enough in development where people can begin to experiment with it, and then we will have a lot of iteration and changes to make as we get real world feedback about how it functions. And I'm very excited for what this year is going to bring, and all the things we will do to improve on the base functionality, all the things we will do to make privacy and compliance possible for augmented reality scenarios, at least as it relates to persistent augmented reality and kind of the domains OpenAR Cloud is interested in. So I'm quite hopeful for what the year holds. I just hope that the pandemic calms down enough where we really can go out to these real world locations and share some experiences.
Colin, people were asking in the IEEE Discord, I'm both registered in the conference and have filled the developing spatial application form, but I did not receive access. I think we will clarify that.
Okay.
Or do we?
Where are you seeing that? I'm in both Discords and I would like to help them.
Yeah,
but, I mean,
it's the IEEE Discord. So it's
which room though?
Tutorial 6 combining. So it's our tutorial channel.
Oh, okay. I'm not seeing that. Could you just let them know? Could you take their name and let them know that?
Thomas here, I guess.
Julia, I have a couple of slides just to do an intro.
Okay.
So I'm gonna
let me stop sharing then. Okay.
Okay.
There we go.
Thanks.
Mm-hmm.
But Rolf, I was going to say, obviously that Discord is not going to be used during this session. It's for during the week. So they're not missing anything at this moment, but we will get them added. I'll try to do it in the next 5 minutes here.
Okay, so we keep on with that, and we now start, I think, with the session.
Yeah,
we have enough to do together.
Mm-hmm.
Okay, you ready?
Yep.
Okay, great. So welcome everybody to the session 2 of combining the virtual with the real. This is where we're gonna get down and dirty and show you guys how to make your own point cloud, how to do scanning, how to add objects, and actually create some rich interactions. So I just wanted to reiterate that if you are joining the session and you're planning to code, or you want to look at the code and follow along, no obligation, but you do need to register so we can make sure that we get you the information that you need, that we can get you on the Discord server and get the apps into your hands that you're going to need. So we really need everybody to go to our website, and the link to register is on our website. This is just an easier link to remember. So I provide this link. And then today, if someone could put this link in the chat window, please, one of the team members. And then the only thing I'm gonna say other than that is before I hand it off to Julia, this is our schedule for the day. So, or for the next 3 hours. So I don't know if you maybe want to take a screenshot of this if you're interested in knowing what's coming next. So the first 2 hours of our 3-hour session is going to be presentations of our different technology options. to give you an idea of what's available. And then I apologize, we have one more that's missing. I apologize. So Immersal is not on here. I'm going to add them. So we have, as I spoke in the first session, but in case you weren't there, we have a browser-based WebXR solution, and we'll be presenting that. And then we have two of our partners that are Unity-based solutions that will be presented also. So we'll have three different options for the breakout sessions. The breakout sessions will be approximately 50 minutes. And then we're going to come back from the breakout session to give you important information about what happens in the third session to make sure you're set up for that if you want to present what you're working on and see what other people are working on. So that's just a quick plan for the day. And we're just gonna go from presenter to presenter. And we're gonna start with scanning. And Julia Bubeau from NovaBee is going to get you started scanning.
All right, let me get my screen shared here. All right, can everybody see my screen?
Yep.
Yes. Okay, and you can hear me? Not on mute?
Yep.
Okay. Okay, great. Well, thank you, Susan, for the introduction. As she said, my name is Julia. I am the CEO and creative director at NovaBee. We are a digital art production company, and we specialize in outdoor augmented reality world scale experiences. So we are members of the Open AR Cloud Association and very excited and happy to be so because we've been working in outdoor world scale AR for several years now, and this is making our lives much easier and helping us create much richer and more interesting experiences. So we're going to be talking particularly about scanning today, but Augmented City is actually a suite of apps, and Vlad is going to be online here to answer questions and also talk about it. I'm going to be talking about the scanning portion. Ali is going to be talking about object upload and placement. Keyboard is not cooperating here. All right. So we're going to be talking for about 15 minutes, and then we'll have a Q&A period, and then we'll move on to Ali's section as well. And there'll be a Q&A between each one. So as I mentioned, Augmented City is actually a suite of apps that help you go from an idea and then find a place to put that content or idea for your experience, and then scan that space and then upload the content or place the content in the space. And then you can use that content or view that content either in an app that Augmented City has called AC Tourist, or you can create your own app in Unity and use that content in there and create your own interactions. And so what we're going to be talking about for the next few minutes is the actual scanning. This is something that is much easier to do than it is to explain. So it's kind of like riding a bike. If you try to explain to somebody how to ride a bike, it takes volumes and volumes of paper, but if you kind of show them or just push them out there to do it, they learn very quickly. And that's how this is as well. You can learn to do it in just a couple of minutes. So it's very quick and easy. So I thought the easiest way to explain this is to just take you through actually an example, a project that we're working on right now called the AMP in Seattle. So this, you can get a sense here. There's a map of the kind of space. It's a large open space as well as some narrow kind of street spaces. This is a big plaza. We've got some greenery, we've got some buildings, so a good variety of spaces. This is the architectural rendering of the space. This is actually a new construction that's occurring. And so there's going to be a lot of public art in this area. And so the reason they were wanting to add augmented reality is to enrich that public art experience and also add some tours. This is a memorial plaza. So they want to overlay some history and culture on this using augmented reality. Here it is in real life, just finishing up construction, one of our beautiful Seattle sunny days, as you can see. So this was actually taken last Sunday. But you can see kind of the surfaces that we have here and different elevations going on. This is just the plaza area here, and there's that narrow street area back here. And then behind me in the picture would have been the park area. And so what we're going to be talking about is how do we go from this to this? This point cloud is what is created using the scanner, and really what your apps or web experiences are going to use to place the content and then retrieve that content to display to you. So these can be a little, once you're in the space, you can really learn to recognize your scans really well, just from the even a low density point cloud, which this is. But for those of you that have not spent as much time in the space as I have, it might be a little hard to recognize. So if you're looking at it, you can see kind of the long axis here. Here is the plaza that we were just looking at. This is the facade of this building, which we were seeing in the last picture. Facade over here, you can even see a bit of the plaza. And then these are the areas that were behind me in that photograph, the park and actually a metro station that you can see in these areas. So in order to create that, that scan, this is a map of where I stood actually to do that. I think what I want to emphasize here are kind of just some of the basic concepts, and really there are a lot of details to scanning, and you know, we could walk you through like click this, click that, but I think what's really important for you guys is to talk about the concepts and the terminology. Once you get that down, then it becomes much more intuitive on how to build your scans. So the main thing to understand is a location in the terminology of Augmented Cities app is the area that you want to scan. So this whole thing would be considered a location. You can have multiple locations within a scan, and we'll cover that a little bit later. But basically a location is a collection of points, and those points build into passages. So a location is made up of at least one pass or passage. 2 are recommended. And then a passage is made up of points. And then to begin your scan, you have to do a calibration. So these things build together from the bottom up to the top to create the map, that, the scan that we just saw. So we're just going to step through those. It's basically a 4-step process. Again, my keyboard's not cooperating. Whoops. Okay, so the very first thing you have to do is to calibrate your scan. And the sole purpose of this really is to, literally what it means is you're calibrating the Augmented Cities measurement system against ARKit, ARCore, or whatever the core system is that your phone is using. This is basically a linear scan where you're just walking along a surface, and it has really nothing to do in terms of the content of what you're producing. After you calibrate your scan, then you're going to create your first point and then a series of points. And so if you blow these up, you can see these are all where I stood to take the scans, and turning in a circle at each of these points, pointing my camera at the surfaces around me. But as you can see, each point is actually made up of a series of pictures. There's generally a minimum of 10, 20 is recommended. Sometimes I do more depending on the situation. And then you take a series of points and they create a passage. So after you've taken kind of a number of points, you're going to finish the passage. This is really for your sake more than for the application's sake. It basically saves your work and helps you organize how you're scanning the area. And then finally, you do another passage. Generally, only one passage is required, but 2 are recommended. It does create a richer point cloud. So next, we're just going to walk through these real quick, and I'm going to give you some tips on how to do this each of these steps successfully. And these are based on a lot of lessons learned, on the ground lessons learned from me. So once again, here's our plaza. And so when I approached this, I basically walked through the site to kind of develop a strategy, kind of mentally inventory the different types of surfaces I have there, and develop a strategy of how I was going to scan this area. So the first thing I did, as I mentioned, was calibrate the scan. Now, as you can see from this picture, there are a number of surfaces I could have used. So why did I pick this surface? So one, it was a nice flat surface. I could stand at a decent distance from it, which was about 5 to 10 meters from it. And I could walk in a constant line as I went by. But the main reason I picked this surface as opposed to this surface is that it was not overly reflective. So reflection, just like computer vision, is very similar to our vision. If there's a lot of reflection, it can be hard for us to discern depth. So this, because it had a finish applied to the windows, created a nice non-reflective surface. It also gave a lot of contrast for the camera and the computer vision to digest, as opposed to here, highly reflective, not a lot of information on that. So as you can see here, when you first start over on the left, it'll tell you it's not calibrated. You'll click on the video icon and then you'll get this screen. And as you walk by, it'll click through and do this automatically in terms of the number of pictures it'll taking, and it will tell you when you've successfully calibrated your scan. So the next thing was to take a point scan or scan a point. And so to do that, you pick your point, kind of, again, mentally thinking about where you're going to be traveling to create your passage. And you're going to spin around in a point, just using your camera and clicking as you go. There are 2 different modes in which you can do this. I tend to use and highly recommend what's called the pro mode or the manual mode. You can access that through the profile icon in the app. But there is this auto mode, and that would guide you and actually automatically take the pictures as you turn. So basically, you're going to turn around. The keys here are to try to keep the base of your phone, the image of your phone, bottom of your screen, actually at the horizon of the building or the ground. So at that vertical horizontal intersection. And the reason you're doing that is that you're trying to capture things because we're creating a kind of a permanent AR cloud in a way, or a persistent AR cloud. We want to try to capture as much of the information that is not going to change. And so because things change on the ground quite frequently with seasons, trash, all of those types of things, it's not always a predictable or consistent indicator for the computer vision to work and for the as a location identifier. So if you're capturing the vertical aspects, those are less likely to change, less likely to be interfered with. And the other thing is you want to make sure you're holding your phone slightly upwards, as I've indicated here. Now, when you have tall buildings, you might think that you actually need to do 2 scans, one kind of at a eye level and one up. And that was a mistake I made initially. You could do that, but it's completely unnecessary and basically doubles the amount of work that you have to do. So the key thing to realize here is actually what your camera is seeing is a lot more than what you're seeing on your screen of your phone. So it's actually capturing much higher and wider than you're seeing. So after you scan your first point, you're going to move to your second point. I generally shoot for about 6 feet between points. You can do that more or less depending on the quality of the scan that you need and the distances that you're trying to capture. So for this, I moved about every 6 feet. There's guides within the application that can help you determine what is the best distance between intervals. And so you're going to just keep moving down the line, spinning around, taking your pictures. It's very quick. I think this pass probably took me 10 minutes, something like that. Once you complete the pass, you hit finish passage. I've made the mistake of not doing that and just doing all of my points all at once. And if you make a mistake, it's easy to lose your work. So I do recommend, dividing your scanning into smaller chunks, and that way you're making sure you're saving it. Okay. And then you're going to do a second passage. So again, one passage in a sense, because this is an open space, in theory could capture it, but I'm going to have a much richer scan with 2 passages. And since we're looking for a high quality scan, I did at least 2. And then you're going to upload your scans for processing. So very easy to do. There's just the send button, but there's a few other things on the home screen here I wanted to point out. So one is it does keep track of your total number of photos as you go and your total number of passages. You can take scans at different times of day. However, it is not needed. You'll have this message, but you don't have to do that. So generally the daytime mode, which you can switch between these different modes here and here, the daytime mode is going to be sufficient and what you need for most situations. If the illumination level of your location is going to be significantly different, such as evening or night, and you want your AR content to be available during those times, then you would want to also take scans during those times of day. Oops, sorry about that. As I mentioned, a couple other things to be aware of on the home screen. The Pro mode that I mentioned is accessible through your profile icon. And this button to me, oops, sorry, this actually brings you back to the screen every time. So it's a home button, that wasn't very intuitive to me that was what it was. When you're uploading, it'll tell you about what percentage you are uploading to their server for processing. I do recommend you keep an eye on that. There's still some things they're working out. So if your phone goes into sleep mode while you're uploading, it could potentially stop your upload. So you just want to keep an eye on that. And then finally, whoops, sorry. Finally, over here, the maximum number of photos they say is recommended is 2,000 for any given location. I say it is a true limit. Not that it won't work, but you will regret going over 2,000 photos. It takes much longer to upload. And also it can just lead to errors, having to upload multiple times. So I've made that mistake a couple of times. I do not recommend going over 2,000. So if you have a location, an area that is going to require more than 2,000 photos, which is actually not uncommon for a large area. So this is the area that we were just doing. I did 2,000 photos just for that, and I still have more to do. So what you'll want to do is you'll have to divide up your area into multiple locations, and then make sure you're just getting some overlap in those locations. So if we go back real quickly, I know we're running short on time here. I have multiple passages that are shown here. This is a little over 2,000 photos. I still have other areas here and here that I need to do. So when I scan those areas, I'm going to recapture some of these areas. Generally about 100 photos is what it's required, so that there's overlap with the new area that I'm scanning. And that those can be bound together into a single location. So finally, this is what you end up with. On the left here, we have what's called kind of a high quality or a more photoreal type of scan, high density scan that you can easily see. What it is that you've scanned that looks more like the real world. But on the right is what you're actually producing. So this is more of a low density scan, which is what will be used in your apps. So that is scanning 101. There's lots more details in the tutorials and further breakdowns, as well as tips in the tutorial documentation. So I encourage you to look at those, but you are welcome to reach out to us at any time with any questions. I will also say that Augmented City did a great job with their help guides within the app, and those are accessible all the time. There's both written and video documentation. So those are great resources and accessible through, once you're in the scanning mode, those are all accessible through the question mark icon. So with that, I will stop sharing and just we'll open it up to see if there's any questions about scanning, and then we'll move to the object upload and placement.
There's one question, Julia. Thank you very much. There's one question in the Discord. What specification phone was used? So what phone did you use, and what specification is needed or requirements are?
Yeah, so mine, I'm embarrassed to say I have a pretty old phone at this point. I used an iPhone 8, but it works great on that. I will let Vlad talk about the range of phones that it can be used on.
Yeah, actually, any recent phone will work fine, and there is no difference between iPhone and Android phones. So the parts of the location can be started with iPhone and then finished with Android phone. So they will all combine automatically, regardless. So that's not a big issue.
Any other questions? Let's see. Do you have any experience on wide open spaces? Yes, we do. So yeah, so we have some large parks here, like Westlake Park. So I've been working on that, which is kind of like a central park area within Seattle. Vlad and the folks at AC have done Sochi Olympic Park in Russia.
That was not 100 by 100, but 1000 by 1000.
Yes. Yeah, so the key there is a couple of things, is really just kind of strategize about how you're going to take the pictures, and almost definitely you'll be running over your 2000 picture recommended limit for any given location. So basically you're going to need to be dividing that up into multiple locations that'll then be bound together into a single location. You actually don't have to bind them together in locations. It's just if you do bind them, it allows you to have a singular experience, AR experience within within those locations. So a location is basically the limit of if you place AR content in that, the geographical limits to which it can be accessed within that location. So for the area that we did, we had to cross streets and those kind of things. So we bound them together so that people on one side of the street could also see what was on the other side of the street. I don't know if that makes sense, but if we already have a point cloud data from photogrammetry software, could we import that rather than using the app? Vlad, that's you.
It really depends. Usually it's not a very good idea because we need to localize them using the same kind of devices. And I just don't know what kind of devices were used to acquire this existing point cloud. So maybe this was a LiDAR. So then it's very difficult to match a LiDAR point cloud against a point cloud captured by phone.
Okay, yeah. I think since I'm the bad guy on the schedule, we should continue with the next topic.
All right.
Let me do the sound check. Everybody can hear me?
Mm-hmm. Yep.
You see my screen?
Mm-hmm.
Yes. So thanks a lot, Julia. Julia has started with the first part of the presentation, which actually is one of the 3 steps. And my name is Ali Hantal. I am the founder of XR Masters. We've been working on city-scale persistent AR for several years, and a member of OpenAI Cloud. Very excited to be in this community, and I am very excited to have all of you guys watching us right now. And please look at our website, OpenAI Cloud, and if you can join, you can help our cause to make this even a more successful initiative. So there are 3 steps to this process, as Julia explained. The first step is how to capture, how to scan or map the environment to get a 3D point cloud of it. And the second part is how you enrich and how you create the content. And in our case, actually, we will be talking about how you would be developing your own AR Cloud Viewer app using the Augmented Cities SDK. And this will be covered in detail later today at the breakout session, where we will talk about practical live demo using Augmented Cities Unity SDK. And Nazih and Yavuz will be giving you Unity, share their screens and give you a presentation and walk you through how to do that. I would like to talk to you about the step 3, which is place and view. And I would like you to know that you can do that only today. We will be providing you the SDK through Augmented City, but that is only for developing a viewer app, a spatial browser app, and not a placing app. So the placement will be done by Augmented Cities AC Unity app, which is APK. You will be able to download it from the Google Drive. It's on our documentation, or you will receive a test flight invitation for the ACO 3D app. One thing that you should know about that app is that app on TestFly shows up as AC Unity. So the APK file is AC Unity. When you see the test flight, the invitation, it is AC Unity. But when you install it, it is called ACO 3D. So if you hear us talking about ACO 3D, that is actually the application, same application as AC Unity. And once you place the AR content that you created in step 2, then you will be able to view the content either using one of our Augmented Cities viewer apps, or what we would like you to see is to use your own app that you will be creating using the SDK. Let me briefly show you the screenshots, and then I'll show you a short video of what has been done in Taksim Square. The application AC Unity, when it's opened up, it just gives you this screen which is say Start AR. You need to be at the location that you have scanned so that the app will localize itself. And when you press Start AR, it actually asks you to freeze the phone, and you would need to hold the phone still up until the visual positioning system works and knows exactly where the phone is. And once that's done, you will see that it's localized successfully. Once it's localized successfully, you will see this screen, and there will be a plus button. When you click that plus button, you will come to the new AR object screen where you will see 3D content, and you will be able to click. Let's say this was the, actually, if you click on this guy, what was this guy's name? Transformer. Yeah, Transformer. You will be able to, as soon as you click on the Transformer, you will see that like a regular AR experience, you will first see that it is going to be repositioned. You can reposition it anywhere you want, but it will not be persistently placed up until you actually click on the add button. Once you add the second time, the add button, which I haven't done it in my first trials, so it doesn't persistently save its location, and you will not be able to see it when you look at it again. So once you place it and plus the add click the add button, then it persistently is placed on your environment. Now you can actually restart the app, and you can, I would recommend switching off the app completely and then restart the app, the same app. And after localization, you will see that automatically you will be seeing what you have just placed. And once that is done, that could be your test. Once you can see with the AC Unity app that you can see what you have placed, then you can actually use your own app that you will be developing with SDK, the Unity SDK, and you will be able to see that. Now, this is a very simple placement and viewing, and I would like to show you quickly how a persistent and shared experience can be in a very wide area. This was in a square called Taksim Square, and let me start with, yeah, it is not only persistent, but it's also a shared one. And what you can do is you can do very good occlusion, as has been done here. So very precise occlusions can be achieved if you can make that on when you were creating the app. And this is how you're scanning, and that's what Julia detailed in her part. This is how she was talking about. You can go and the app can help you to scan. And once you do spin around, of course, this is not going to spin around all the way. Basically, then you can start creating your content. And this is the point cloud of the square. And when you create the content, you will see that now it is persistently placed, and it's a shared experience where you would be able to see it through different devices, and very soon on HoloLens as well. We're working on that as well. So this is what I wanted to go for the placement app. But here is important part about session 3. Once you work on all of these new stuff, we would like you to get your work submit to us the day before on April 1st. We will be providing more information on that. And actually Ralph, who is here, and I will be on the Discord channel. And please ask any questions if you have for the demo day there. And we will have the demo day on Mozilla Hubs. Here is the link, which you will have that link on documents as well. And once you are on the Mozilla Hub, even before that, we will have onboarding sessions. Please check out the documents, and we would be glad to help you before you get on that demo day to get for the onboarding session, get used to it if you have never been on Hubs before. And I guess this is what I wanted to cover. So if you have any questions, please let us know.
Are there questions about the object placement and viewing?
Just a general comment to this. So we have a so-called administration tool where we can actually see all the locations, all the mapping, and all the objects added. So if you have some problems or some doubts of whether object was placed correctly, you can ask us, and we'll just show you online where you are. Yeah, thanks, Julia. So that's how it looks like.
So just to be clear, the participants won't have access to that, but that's a tool that the team can use, our internal team, to help them. No questions? Then we can take a 5-minute break. So be back at 11:45.
Yeah, thank you.
Thank you, everyone.
I have to have it in less than 5 minutes. So I will start. Yeah. So hello everyone. My name is Michael Salazar, the main developer behind the GeoPose Sandbox, a test platform that has enabled our standardization group to not just validate the conceptual layer behind one of the main pillars of open spatial computing platform, but also to define new interaction techniques with it. Because I don't know about you, but as a UX designer myself, every time I hear about amazing technologies like reality capture, spatial mapping, or GeoPose, there is always a voice in my head that says like, how can I take advantage of this to create more engaging user experiences? However, before we start designing new interaction spaces, we need to define what a space actually is. Because in most use cases, we operate with virtual scenes in limitless Euclidean spaces where we can place whatever we want and simulate things with relatively simple math. But turns out that the Earth is not flat and that the speed of light is not infinite. And that when we have to think about how to represent in augmented reality an object beyond the horizon, or one that it is so big that we have to take into account the curvature of the Earth, we need to define a more advanced system. So, let me see. That's why we are defining the GeoPose standard, to allow developers to overcome all these issues and to create interoperable experiences across the globe and beyond. Because while the basic form of GeoPose is designed to facilitate the placement of objects relative to the surface of the Earth, the objective of the standardization group is to provide a diverse system to define the pose, that is, the position and orientation of objects in any kind of a space or subspace. To this end, in the GeoPose Sandbox that I have been working on, we are taking into account not only the indoor and global positioning systems, but also including ideas from the NASA Space Toolkit to deal with orbital mechanics and the associated relativistic calculations so that we can operate at any scale. As for the orientation part of the pose, of the GeoPose, the sandbox provides the mechanism to translate between different rotation systems, such as aircraft principal axis, like the pitch, yaw, and roll angles in degrees, the more common Euler angles like X, Y, and Z in radians, and quaternions. They operate with four-dimensional complex numbers to enable better interpolations. We even include a lookup mechanism so that we can orientate entities in relation to others. For example, reorienting a solar panel on a satellite or on orbiting the Earth so that it always faces the sun. And even if the inclusion of all the systems into the GeoPose standard look like over-engineering, the truth is that it opens the door to the creation of experiences across different countries and time zones, but more importantly, across the mental barriers that limit the communication between different industries. Like there is the engineers in the aerospace industry that don't communicate with any other industry, and there are a lot of communication problems. So to combat that, we have created this idea so that we can have the ability to build experiences with interoperable and reusable components. Something especially important in the physical world, in which the increased presence of robotic systems like drones or autonomous vehicles require the development of new navigation systems that not only allow all types of agents to better plan their movements, but also to communicate those movements so to avoid possible collisions. And finally, this navigation turns into discovery when, thanks to the OpenAR cloud, these agents can finally find new user experience by simply moving around the physical world, which for us human beings means being able to recover that sense of wanderlust that we feel when we explore our surroundings for the first time, finding new interesting experiences on the go without having to deal with URLs, search terms, or QR codes. But one of the most interesting application of GeoPose, especially for this conference, is to use the same code to post an object not relative to the Earth surface, but in a spherical subspace around the user. Because as you can see, every element of this presentation is actually a 3D user interface, of a 3D user interface positioning and oriented using GeoPose to create different layers of interaction. And from a point of view of a user situated in the center of this subspace, it allows access to the different elements by simply rotating the camera, and something that it is especially useful when you are using a VR headset, because you only have to look around to access the entire experience. And this is just one of the examples that can be achieved with this, the GeoPose sandbox. Because, for example, we are using the same technology to create the prototype for the GeoPose website. And there are other many possible applications to create user interactions with the same code. If you want to play with these concepts or create similar 3D user interfaces, you can go to our GitHub repository and continue from there. And if you want to contact me, please send me a message through GitHub and I will answer as soon as possible. In the meantime, if someone has any questions, please let me know. Because I guess there are way too many, or I have to explain better how this can be used, because while the GeoPose sandbox only needs the data part to enable the communication between different entities, between different agents, by creating a logic layer and, more important, a user interaction layer, we can create 3D user interfaces that actually take advantage of this technology to create much more than just simply placing an object in the real world and being able to track it, but being able to have objects that follow us, or being able, this technology enables us to present the GeoPose information in a much more clear way. And while this is a very experimental and there are things that I am going to add tomorrow to this GitHub repository, I will be very happy to explain and to try to find new ways to take this technology beyond just merely placing one thing on top of the other. Okay.
Thank you, Miko.
That's 10 minutes at most, but if anyone has any question.
Could you paste the link to the GitHub in
Yes.
the chat? Thank you.
One thing I think worth mentioning that is really unique and powerful about GeoPose is the system's designed in such a way that it's very useful on Earth, but as we start seeing more low orbit commercial space ventures, the same coordinate system can extend into outer space without distortion problems. And that is one of the powerful things that comes with this system, so that it is not skewing to the surface of the Earth. And we like that, because I think one day soon, augmented reality in outer space will be happening.
Yeah,
and we'll be ready for it.
Yeah, and we can track things like the International Space Station with augmented reality, because we can translate the orbital parameters of that spacecraft into GeoPose and vice versa. So that is the power of having the math to do that.
Okay, we still have some minutes for for questions. We know it's a lot of stuff that's coming, and it's probably not easy to get orientation. So please ask, because we have some narrow focus and are not aware of several questions that might be obvious.
It would be easier if we were a commercial venture, because then there would be one product and one path.
Yep.
But because we are a consortium trying to forward an open interoperability model, we need to demonstrate, N+1 solutions that allows, proves that this really can be an open ecosystem, and that many different interests, both commercial and private, and also public and government, can all have a shared canvas for painting the world with data. And
yeah, maybe hopefully everybody understood all the pieces. We were talking about scanning, so this is more or less a practical thing that has to happen to place things. We have been talking about, Ali is talking about placing things. Now Mikkel gave some showed his tool, and which might help in understanding orientations, which always with 3D is not that natural as on a 2D surface, and but is important for all that applications. And so now I think the next topic is, if there are no questions anymore, is Susan. She will present our cesium demo and the dev environment.
Yeah, and Gabor is going to support me on that. And I think that the cesium demo is another way of looking at GeoPose. And so on the one hand, it's complicated because we're showing a lot of different things, but on the other hand, you are getting different perspectives. So maybe in some cases it's more confusing, in other cases it'll be clarifying. So let me get started with the cesium demo. Let me get my screen ready, and then I will share it. So you can see my screen?
yes.
Yes.
Okay, thank you. Because I can't see myself seeing my screen. So the browser client cesium visualization is a way to kind of see GeoPose working. It was one of the first tests that were done to make sure that the reference API for GeoPose was working. And so I'm going to talk a little bit about that. Cesium is a service, a geospatial informational GIS service, and it has, among many things, it has 3D data, and so we're pulling that data in to show, mapping an image over that data to show that the image is in the right location. So let me get going with that. My test location is in Pershing Square, downtown Los Angeles. So as Julia was already talking about, I went down there and took many pictures of this particular location. And this is an image of my scan over here. You can kind of see this artwork showing up. And so, as Julia talked about, when you take all these images, a point cloud is created and it's being stored in the cloud. And anybody jump in here if my understanding is incorrect. But the system knows every geopose of each point, right? And so when you have your camera, your AR camera is looking in your space that's been scanned, it's looking for unique points in the camera view, and it's trying to match those to the scan. And so this is the way that when it finds a match, it knows, since it knows the geopose or location of the points in the point cloud, it can triangulate and figure out where the camera is, and thereby show the AR objects. So let me just, I'm going to kind of give a demo of the project, and then Gabor is going to go into a little bit more of the technical details of how to actually set the project up. So I have everything already set up, and I'm just going to run it here. I'm going to run it. Why isn't it going? Command prompt. Dev. Oh, there we go. Don't know what was happening there. One thing I do want to point out, and this is all in the documentation, I'm just kind of giving a high level overview of particular points. One of the things that you'll need to do is go to Cesium and get a token so that you have access to their database. So when you go to Cesium and you log in to an account, you're going to go to access tokens to create a token. And this is the thing that you want to bring into your code. I have the particular file already loaded up just to kind of show you. It's down here on this line, and it's well documented. It says exactly where in the code to do this, and the documentation tells you which file. So it's actually, even for non-coders, it's fairly easy to follow. There's only one point that's a little bit of a gotcha, and that's creating your local server. And we're here to help you if you get stuck on that. So when the application is ready, I'm going to take the URL and just place it into my browser. And so now the client is running on my local machine, and this is the access to, this is also where you can see, where you can access the spatial discovery service and spatial content service. Okay, so the demo is here, the geopose. So we're going to click on this, and what it's trying to do is it's asking me also, by default, the application is selecting the augmented city as the content discovery service, because that's the one that's been integrated with the open spatial computing platform. So it's going to ask you like to put in what discovery service you're using, and by default that's the one we're using. So it's already ready to look into the cloud, the database at Augmented City, to look through the point clouds and try and match my photo with a map, a point cloud in the database. So the photo is simulating the camera if you were at the location live. So I'm just going to select a photo from the, where did I have my photo? So I'm just going to select a photo off of my drive to localize. So it's going to take the photo and look for unique points within the photo and try to match it up to the point cloud in the database. And if it finds a match, it's going to send back a geopose of the photo, which is a position and an orientation. and it's going to mimic as if the photo was the camera. There we go. So that's the lat long and the quaternion. One thing that's important when after you've taken your scan, which is the first step of anything that we're doing, once you've gotten your scan, when you are trying to use this app to test to see if it's working right, you want to make sure that you have the metadata in the photo of your location. So it knew already what the lat long of the photo was, because that's metadata that's that comes automatically in your photo, but you have to make sure you turn location on your phone in order for that metadata to get saved. So once it knows around where you are, it knows to look for a database that's in that area. And so it worked because I got the geopose back, but then I'm going to show you now we're going into the cesium database and looking for the cesium geometry to match with the photo. Oh, I'm sorry, I should probably have this full screen. So you can see that this building here is right here, and then this building here. Oops. Sorry, there's a wall there in my way. I'm gonna.
The wall is sort of
Oh, I see.
the camera.
Okay. Yeah,
smartphone.
I gotcha. Okay. Thank you, Jan Erik. So, oops. Should I refresh? Or was the point gotten? So the mouse control of moving the image is very sensitive. So I'm not sure how to get it back into.
I think it's okay. The point is that you appear in a representation of the real world that is three-dimensional.
Yes. Okay. So
well, and also it's, I think, important to point out that we're able to align multiple data sets coming from different sources. And this practically demonstrates how you can take an ad hoc photo and align it to a pre-existing, cesium tile, which is one of the most ubiquitous kind of available data sets in this space right now.
I don't know why it's being so sensitive with me today, but hopefully you were able to see how they were lining up and how it knew where the photo was just by the visual matching up of the points. So Gabor, are you ready to take over?
Yeah, yes, please.
Okay.
You have to stop sharing before I can.
Yeah.
Okay, I can share this screen. Let's see. Is it sharing now? No. Better now? Can you see it?
Yep. No, we can. Mm-hmm.
Okay, so this is a same example, me walking down the street. So I took a photo, this was the query photo, and then it placed the map, placed the photo and the camera right on the map. This is roughly really the geometry. Here around me in Budapest, the geometry of cesium is not so accurate. But the great thing about cesium is that it really has these different types of layers of input sources. So you can load OpenStreetMap, you can load other types of if you have point clouds, you can even put point clouds. They have these 3D tiles format for storing all kinds of things. You can even add GLTF files. So I encourage you to actually test it out at this deployed example. You can use your own photos if you are ready to map your environment, because as Susan mentioned, this demo is now using Augmented City as a localization service. In the future, there will be, of course, other services in the back. We planned to, so I created some walkthrough. Why cannot I switch the slides? Okay. But in the interest of time, I will just quickly go through it and don't type it myself. You can do it at home. It's really literally takes 15 minutes to install this thing on your machine. If you even don't want the 15 minutes, then you can just go to the website and try it out with your photos in Seattle or other places that are mapped. What you need for this is basically just a Git client, Node.js, like a Node package manager, and a normal code editor like Visual Studio Code. And you need to register a Cesium account, which is free, but takes a few minutes. So you basically go and check out the code. These slides and also comprehensive documentation that I wrote based on these slides will be handed out just after this. So you don't have to take pictures or take notes. You get all this. Then to be able to run your local server, you have to create an SSL certificate, which is the most difficult part of the whole thing, installing OpenSSL. Then you need the Cesium token, and currently there's a manual step that you need to copy some files to make Cesium work. You have to put them into the public folder of your web service. Then just run npm run dev, just as Susan did, and you get it running. It will write out a URL, and you can paste it in your browser, and there you go. I also wanted to show a few lines of the code. I won't go into the code editor now, but I highlighted here the most important parts. So the whole thing is a Svelte application. It basically loads a photo, reads out the EXIF tags, GPS, like course location. This is just to initialize the visual positioning service, because you need to know, you cannot search the whole world. You need to know which local map you need to search. It also submits the orientation of the photo. It helps also the positioning system if you don't have so many possibilities. Then an important thing that we need, in order to find the GeoPost service, the localization service, we need first the country code, just like a top-level domain in a DNS. And we find this out by an OpenStreetMap reverse lookup from the GPS coordinates to the country code. And based on that country code and an H3 index. So H3 is a hexagonal multi-layer grid on top of the surface of the Earth. I think it was developed by Uber. So that is basically a coarse grid on top of the surface of the Earth. So we don't need the exact GPS positions when searching for the service, only a coarse location. And then the SSD, the Spatial Service Discovery service, will return you a number of possible localization services. We default now to Augmented City because we create the point clouds with that service. Then we assemble a request which contains the camera image and the geolocation. Other visual positioning services require only the sparse features, but this service requires a full photo. You upload that, and then the reply you get latitude, longitude, and also the orientation. Then it needs to be a little bit of matrix magic needs to be converted to another format that Cesium can visualize. I will talk about this more in the second half of the tutorial. And we just create a sample terrain, load OpenStreetMap buildings. So this is the course level, and place the camera to that position. In this demo and the code that we give out, it's only the camera that is positioned, but it could be used as a nice debugging tool to also place content. This is at the moment, I think, not implemented. But if you don't want to map your environment, which is a requirement for anything else in this tutorial session, then this is a nice example of, for an idea for the week to add some content in here, like matching the Cesium demo client together with the content discovery service. And then you could place content. This would be a nice debug view of what is going on, what is placed there, where, with all the 3D models. Yeah, so yeah, the important thing to note is that the photo needs an active tag because we need the coarse GPS position, and it only works when there's a point cloud already mapped by Augmented City. Yeah, then let me just see. Last comment I wanted to make is that on the top, when you selected this GeoPose application, the same web service offers a developer tab where you can look at these H3 hexagons. So you can easily search for a certain GPS position for the H3 index and so on. It's for debugging, so you can convert between. And yeah, so this is the address to try it out. And if you have any questions, feel free to ask. I also have a demo here where it runs on the mobile client. This is basically the same what Susan showed, but with the photo is already preloaded. What is cool here is that when we use this on a mobile and we use Cesium not as like a full web view, but as an overlay on top of something else like the camera, you can also visualize, for example, building models that you download and that are not built yet. So you can actually look how it would look in the future, or how it looked in the past if you have historical data. So that's all I wanted to say at this point, and I'm happy to answer questions if there are any. Thank you.
Thank you, Gabor. So, any questions?
So even in the same,
sorry,
even in the same demo, you got two very different views. So the technical and the non-technical.
I forgot to mention an important application is when you download these building models, those can be used as occlusion geometry, of course, for in AR. So this is an important thing, and I think many other AR engines do something like that.
So with the demo, it wouldn't be a problem to get the camera image in it. So if you want to have the impression of occlusion.
Here, so we have. I will talk a lot about getting the camera image in the next session, but it's not trivial to get the real camera image if you want.
It's easier to do with the Unity stuff. This one is easier in the native. Okay.
Yeah, yeah. So this is more a debugging and visualization tool that helps by developing the other apps.
So
it was our initial proof of concept.
Yeah. So there's the question, any performance information, e.g. accuracy, latency? I think we had this question in session 1, but maybe Vlad or Miko can give.
I can answer. So in the first session we answered about accuracy. So typical accuracy is like 10 centimeter, but it depends on the scene. Actually, it can be much less and can be more. As to latency, currently, at least for Augmented City, localization takes about a bit less than 200 milliseconds. So that's the typical time, that median time that can be expected. So currently, the biggest bottleneck is the uploading, actually, the frame. So latency related not with the localization, but with the transferring of the data. So that's why 5G is a high hope for us, because we believe those latency issues will be solved with 5G.
And these latency issues, I mean, localization doesn't need to happen at every frame. This is usually hidden. There is some AR core or AR kit session running a SLAM on the bottom, and then a periodic request for localization is sent just to pull back the drift that is accumulated in the VIO.
From I'll just chime in there from a user experience standpoint. The only time you kind of encounter that localization and latency is at the very beginning. It's happening all along, but you only are kind of aware of it at the very beginning of the load.
Okay, so let's head on.
Well, I think let's address this question. I think it's important. 10 centimeters is a little big for an AR application. So does someone want to speak to that?
Yeah.
Because
So,
this is
yeah,
the difference between spatial and, yeah.
As I said, this the accuracy actually highly depends on the environment. So if we are talking about let's say indoors localizing something on your desktop, then there is definitely not 10 centimeters, but well, 1 centimeter or even millimeters. Depends on distances. But 10 centimeters is a typical distance, typical accuracy for long distance localization, like when we have objects 100 meters far from us. And for these distances, such accuracy, well, it's not errors in localizations are not visible by the eye. So that's hopefully this answers the question.
But we are optimistic that this will improve over time.
Yeah, definitely this can be improved. So this also depends on the optics used, and we know that every new phone improves in this direction. And also this depends on the lighting conditions. So if nothing can be seen, then there is no accuracy. So that's.
And don't forget that this is an open system. So as a user, you can have 10 different localization services running, and you can just evaluate and choose the one that you believe is the most accurate.
Exactly.
And keep in mind that this is we're talking about spatial computing, so it's a different paradigm than, you know, using an image target. It's connecting with the real world, and so it's a completely different paradigm. And our new partner Zapper, one of the things that we've been talking about is getting the geolocation using open spatial computing platform, but then once you've localized, allowing something that's more accurate like Zapper kind of take over the AR experience at that point, something that's able to be more accurate.
I would, so there's another interesting question, but I would suggest to continue, and I will keep track on the questions coming up, and we will have the breakout sessions. There will be space to answer some of these, so to stay in the schedule somehow. So next is Miko. He has been introducing in session 1, giving a short overview. You'll probably get more in deep now.
Okay, so no need for a quick intro then.
Perfect.
So I will be demoing our demo app, which we released this source code for, which is going to be used in the tutorial session. So we will provide the links after the session, I believe, to the GitHub repository. So I'm going to be fearless today and try to do a live demo. Let's see how this works. So I'm gonna switch to my phone now. Just a second. Okay. There's some feedback. So can you hear me?
Yes.
Yeah, we
Okay.
can hear.
Yes, so I will share my screen. Okay. I guess you can see it now. So I will start this demo app now. So we have an SDK that has been available for almost 2 years now, and it's free even for commercial projects. So you just have to register a free account there, and then with the account you can log in to this app also. So I will now tap the login button. There are 2 modes, the automatic mapper mode and content placement. So I'm going to start with the automatic mapper. And I'm trying to create a quick capture of my living room. So I'm just going to walk around and it will automatically capture 40 images. We have limited the amount to 40 so that the map construction time will be short, something like 10 seconds. And I guess we're almost done here. And I'm going to name the map. And submit it to our cloud service for construction. And I can now switch to content placement mode. And we should see the map here. Yes, living room. I will select it. And when it's done constructing, it should localize automatically right now. Okay, now you can see the actual point cloud of the feature points it captured during the localization, the capturing phase. So for some reason, it didn't get any feature points from that direction, but anyway, it looks good. So we're now in the content placement mode. So I'm gonna click this button on the bottom left to add some content, a cube. And I'm going to add another one here. You can also drag these to move them around. Well, maybe one here as well. Oh. Okay, so I have now 3 cubes in the scene. And what I'm going to do next is to force quit this app and restart it. And now I will go directly to the content placement. I should turn off notifications. Content placement mode, and it will localize very fast. And you can see that the content is persistent and everything is where I put them. And just to demonstrate that this is actually using a geopose localizer and all this AR content is positioned in global latitude and longitude coordinates, I will switch back to my laptop. Hold on a second. So I will share my screen again. Can you still hear me?
Yes. Yeah.
So yes, so this the developer portal, you should also see the map there now. Yes, it's here. You can also check out how it looks, the point cloud, or even the textured mesh, what it captured. Okay, what I'm going to do next is I have this real-time database that we are using, back4app.com. You can create your own free account there and use that instead of using this our account. But anyway, I'm going to these are the 3 objects that I added with the app. So I'm gonna add one more manually. I'm just gonna copy paste some lat long coordinates from here. So this will take a bit of time and it looks boring, but these rotations I can leave empty for now. I'll just copy everything from the other objects. Okay, and done. And now I will go back to my phone again. So just a second. Okay, now that I'm trying to go to the Zoom session with my phone, it's asking for a meeting passcode.
Oh, for this?
Yes, it didn't happen before. Let's see. Try again.
You just
You want to make sure you are logged in Zoom account. Maybe you logged out the first time.
think you're in.